Making dirty water clean again. By Flynn and Riley Nolan from Sydney, Australia. We have a very dirty waterfish pond, and we wanted to copy the way that nature cleans water. We saw some TV specials and did some research. We found that by using drag from bubbles, tubing in the form of an Archimedes screw, to lift water, we can use siphons and gravity to move the water back down. By moving the water through still gravity wells and filters to trap particles in the water, we designed and built a way to make water cleaner.
So Riley, where does the air go?
The air pump pumps the air through there and mixes it around in there. And then there's this one here that pumps the air, and the air pushes the water all the way through here. And then the water and the algae comes through here, and the algae gets caught along there.
Okay, so we've turned it on. Okay, the algae's going in.
Oh, I don't want to spill any.
Like you did.
Tiny bit.
Quite a lot. How much water is that? Huh? How is that possible? A tiny mug held that much gunk in it.
Okay, now,
Doesn't make sense.
is there any algae starting to be caught?
Yes, there is. I can see dirty water being pumped through.
So
It's going through there. It has to...
See that? Look at
over
right
here. There's a little,
different colored.
you can see little bits falling down.
It's stuck. Look, there's water piling up there.
No,
It's
that's
meant
the
to.
point. That's the point, Flynn. That's where all the algae goes, and then it gets pushed along through there.
I
There's
can
a
see
lot of
algae coming in.
Yeah, there's a lot of it going down.
do you want to point the camera to it?
Maybe, no, not like that. Give it. There's a lot of algae falling down across there, and then it gets caught here, and it fills up all the way to the top. Oh, there's so much algae.
You can really see the algae falling on this one now.
There's big chunks falling down. Look at that.
That's
There's a lot falling out of the pipe. If I move that back down there. And then it follows this pipe up down to there, and it cycles down through the filters.
The filter goes up the tube, goes down in here, and as it's being pumped, well not pumped, but as the water is flowing through the pipes, it will go down into here with all the algae in it, and the algae will get caught on the rocks, flow up, and then flow into the next container, which has the rest of the rocks. So if there's any more algae that is in smaller pieces, these are more smaller rocks and a bit more compact together. So it should catch all of it. But if still algae is able to get past, then it's gonna get caught on these rocks, and then the clear water or water that has a tiny bit of algae will go in, and it will pump all the way through back into here to make this cleaner water, and then it will keep on going until the full system has worked and it's all clean. No, I mean like in the game.
We were at a local science fair, and soon discovered that we could not answer all the in-depth science questions about how it all worked to the judges and people. Much of the science magic is hidden in the simple way that nature does things, which we have used in our device. So we wanted to show the hidden science. Our dad calls it accidental science, because we just built and changed the device first, and only discovered and understood the science afterwards. As we now understand it. The intake pipe has an air tube inside which makes the bubbles. As the bubbles rise using the force of buoyancy, because they have a lighter density than the surrounding water. The curved tubing causes the bubble to create the drag force, as it created friction when it touches the sides of the tube. Then gravity draws the water to fill the void generated by the buoyancy effect. This drag then lifts the dirt within the water behind the bubble along the tube to upper levels of the device. The Archimedes type lifting tube uses the lowest part of the curves to capture water as a holding reservoir. This stops the bubbles rising and causes the bubbles to burst. The released air is now trapped behind the water in the reservoir, which blocks the flow. When enough pressure is achieved, a new bubble is formed as the air forces its way through. This new bubble drags the water and the dirt in it up to the next part of the step sequence. In this way, the water can be raised to good height, which is only limited by the total pressure of all steps being greater than the pressure provided by the air pump. Our first set of filters are gravity still water drop wells. The water surges though the tube over small rises and settles in a valley. Each valley has a drop tube reservoir collector. So just like in nature, when the water flow slows, heavier material sinks to the bottom. We use a number of different siphons to transport the water between the different filters from the highest step to the lowest step. The siphon has its inlet at the top of the container, and the outlet at a lowest of the next container. Because the inlet is at the top level of the water, it restricts the objects in the water from entering the inlet, as only the surface skin of the water is able to pass into the tube. The siphon has a U-shape at each end, to ensure that the siphon is always primed by never letting air in the tube. The water has to pass from the outlet through the filter material to the inlet. We use reducing size of materials from stones to pebbles to gravel to plant fiber, which captures particles that pass by in the water. As you can see our results moving from left to right. The first test tube is the original water, the second is the gravity well capture, the third is water captured in the stones, the fourth is the pebbles, the fifth is the gravel, and the last is the fiber, which is returned to the original source. This device and our presentation would not have been possible without acknowledgement and encouragement or support from the following people. We would like to thank endowed Professor Mo Jamshidi, chairperson and founder of the World Automation Congress. Our school's executive of Lane Cove Public School and St. Ignatius College Riverview. Mr. Tan, Ms. Ramaeus, Ms. Lachuka, Ms. Dreverman. And our science and maths teachers, Ms. Clearly, Ms. Kalita, and Ms. Anderson. And finally our parents for helping us build the device and helping with this video. We would also like to acknowledge iHeart Science, Australia, and their Young Investigators Science Fair, who allowed us to demonstrate and refine the way we described our device to others.